Function prototypes. Ah. It's now considered good form to use function prototypes for all functions in your program. A prototype declares the function name, its parameters, and its return type to the rest of the program prior to the function's actual declaration. To understand why function prototypes are useful, enter the following code and run it. All right, I will. See. Used warlike copycat. Include void main. It's a little different, isn't it? Let's do all this. Void main, curly braces, print. Integer format specifier. No, we didn't do that right. So there's that function, and then there's this one. Int add int I, int j, return I plus j, and run it. I'm getting exit status 11 this time. What are the warnings about? Return type of main is not int, right? This this compiler doesn't like it when you do void main. It would much rather do it the other way. It was integer main void. Let's try that. You wanted me to try different things. I'm going to try different things. Now there's only one warning. Implicit declaration of function add is invalid in C99. Huh. It's not because of that, is it? No spaces there. No, it's the same thing. What is this? It's generating different values each time. This code compiles on many compilers without giving you a warning, even though add expects 2 parameters but receives only 1. It works because many C compilers do not check for parameter matching either in type or count. You can waste an enormous amount of time debugging code in which you are simply passing 1 too many or too few parameters by mistake. The above code compiles properly, but it produces the wrong answer. It doesn't look right to me. It's producing this giant number. It's different each time. To solve this problem, see, let's place function prototypes at the beginning of, actually anywhere in a program. If you do so, C checks the types and counts of all parameter lists. Try combining the following. All right. Int. Function prototype for add. Void main. There's that print statement again, and then int add int I, int j, return I plus j. Okay. I just get an error, buddy. What is going on here? Int add int. Expected 2, have 1. Oh, they expected an error. Prototype causes the compiler to flag an error on the proof statement. Place one prototype for each function at the beginning of your program. They can save you a great deal of debugging time. And they also solve the problem you get when you compile with functions that you use before they are declared. For example, the following code will not compile. Why, you might ask, will it compile when add returns an int, but not when it returns a float? Because older C compilers default to an int return value. Using a prototype will solve the problem. Old-style non-ANSI compilers allow prototypes, but the parameter list for the prototype must be empty. Old-style compilers do no error checking on parameter lists. Oh my gosh. Is this useful? There you go, it does generate an error. Conflicting types for add. But if I do int, it compiles but gives you a weird answer. So the whole point of this was to create a program that would generate an error, I think. And to add, by adding the function prototype, it'll catch errors like this one. Yeah, this is not a good beginner lesson, I don't think. This particular chapter. Go back to the bubble sort example presented earlier and create a function for the bubble sort. Did that. Go back to earlier programs and create a function to get input from the user rather than taking the input in the main function. Well, we've done that too. So I think I'm going to stop there.